Hello everyone and welcome back to your channel Physics Safari. My name is Abhishek and today this is gonna be the second lesson on kinematics. I'm sure you must have gone through the previous video lesson where I discussed about the displacement, distance, speed. Today I'm gonna discuss about the average velocity, average speed, and of course instantaneous velocity and the instantaneous speed. So when we talk about the velocity, when the velocity comes to your picture, to your mind, it should be of two types. It's going to be instantaneous velocity, or it is going to be your average velocity. Average velocity. Instantaneous is very simple. That is going to be your ds upon dt. Instantaneous rate of change of the, rate of change of the instantaneous displacement. Now, when we talk about the average, that should be given as the total displacement, or you can say the net displacement, total displacement upon the total time, That would be your V average. Now, this formula only suggests that there are going to be some time period elapsed in between. There are going to be some time period over which we have to find the velocity. So that is the reason why it is called the average velocity. All good? Now, there is a particular way of solving these kind of things when we talk about the average, and I would expect everyone to remember the formula, to work with the formula according to the formula. अच्छा, कुछ इसके बारे में बातें करते हैं हम लोग और. Now, when I say average velocity, so V average, this is one of the finest way of finding the average of anything, be it your average velocity, average force, average displacement, कुछ भी हो, ये तरीका याद रखना. Now, average velocity should be what? Over a period of time, so let's suppose dt, and I'm going to integrate this for the time period, let's suppose 0 to t. Over the total time, that should be dt over 0 to t. इतनी बातें clear है. Now, velocity, which is instantaneous velocity over the small period of time dt, if I do integrate that, that should give you what? That should give you small displacement and integration. Now the limit should change to what? 0 to the net displacement, we can say, and time periods limits would remain as it is. I'm like, that's okay. Now this is going to give you what? Net displacement upon the total time taken, and that is your average velocity. Keep this in mind, very important. You just have to integrate this, and over the integration of time, so for a small time, for any period of time, अपन को ये मिल जाएगा. और हर एक चीज में this is going to be helpful, याद रखना. This particular pattern is going to be helpful. चलो, तो इतना तो समझ में आ गया जी कि the average velocity is all about the total displacement upon the total time. हम लोग ऐसे निकाल सकते हैं. And this is when we have the continuous function. The velocity is dependent upon time, and we have to find the average velocity. This is what we're going to use. All good? Don't do that, v1 plus v2 by 2 if it is not the continuous function of time. I'm like, if it is a continuous, it is a function of time. थोड़ा और बात करते हैं average speed के बारे में. So speed we will be having the same thing. It is going to be your average speed and the instantaneous speed. You can just split this in two parts, average and instantaneous speed. So instantaneous speed is not a big deal. It's just going to be, so you can say this is your speed, and that is going to be ds, the magnitude of that, upon dt. All good? So that is going to be your instantaneous speed. अच्छी बात है. Average का देखते हैं. So when we talk about the speed average, same stuff. We are going to follow the same rule. So we should be having what? Mod of dv dt over a period of time 0 to t upon dt for, let's suppose, 0 to t. कोई दिक्कत इसमें? नहीं ना? Now, this is going to give you what? This is going to give you this, the net distance, right? The small distance, you can say, and the limit should be 0 to s, like that. And over here we'll be having what? Same, 0 to t. That would give you the net distance, the total distance that would be given upon the total time. So that is your you can say average speed. Speed, average you can say. Well, this tells you what? The total distance. That tells you the total distance. इतनी बातें तो clear है upon the total time. Upon the total time. ये दो बातें आप लोग लिख लो. Note it down. You can pause the video, note it down. It's important. देखो, if you want to have an example on this, चलो एक example देखते हैं. Let's say, we have a force that is a function of time, and it is given as, let's suppose, t square plus 2t, something like this. I want to find the average force. I want to find the average force, let's say for time period, for t is equals to 0 to t is equals to, let's suppose t is equals to 0 to t is equals to 2 seconds. What I'm going to do is, so F average force should be equals to F dt, integration from 0 to time period is how much? 2 upon the total t, let's say dt 0 to 2. I have taught you the integrations a long time back, in probably in the 5th video of the basic mathematics for physics. You can search or you can find the link in the description box to watch the integration method if you are not well aware with this integration. Anyways, so this is going to be how much? F is how much? T square plus 2t, let's say dt, integration from 0 to 2, and same over here, it's a dt 0 to 2. Now integration of this should going to be how much? T3 upon 3 plus 2t square upon 2, and the lower limit is going to be 2, 0, and the upper limit is going to be 2, and here we're going to have what? T, and the lower limit is 0, upper limit is 2. Now this you have to put the limit. All the way, that's going to be how much? 2 to the power of 3, that's going to be 8 upon 3 plus, anyways, I can cancel this, 2 square, that is going to be 4, upper limit is now done. Let's talk about the lower limit. If I put 0 in place of t, I should be getting 0. This should be getting how much? 2 minus 0 is going to be 2. So that is going to be your average force. So solve. We can have what? 12 plus 8, 20, 20 by 3 by 2, so 20 by 6. That should be how much? 10 upon 3. Let's say Newton. So that is going to be your average force. I'm sure it's clear to you that how to find the average velocity or anything. If it is the average is given, we just have to find the integration over the period of time and total sum basically, and then over the total time for which these all changes took place. All good ji? Kar dikkat isme? ठीक है. I'll make a note of this one. I can pause the video and note it down. Okay. Meanwhile, I would just erase this. इसको थोड़ा साफ कर लेते हैं. Okay. Now we shall be heading towards the average acceleration. We shall talk about the average acceleration. थोड़ा इसको साफ कर लेते हैं. बहुत अच्छे. सारी एक्सरसाइज इधर ही हो जाएगी आज तो. ये लो भाई, it's now clear. अब थोड़ा बात करते हैं एवरेज एक्सेलरेशन का. तो मैंने से एवरेज और सिंपल सी बात है एक्सेलरेशन का बात करते हैं. Let us talk about the acceleration. Same thing, we have two kinds of acceleration broadly, instantaneous acceleration and your average acceleration. All good? Now instantaneous is all okay. We're going to have what? Change in the instantaneous velocity. So that is going to be your average, instantaneous acceleration जी. Average का same, वही same formula अपने को apply करना है. So your A average should be given as A dt upon your dt. You need to put the limits 0 to, let's say t, 0 to t. Not necessarily that it has to be from 0. Just मैंने ऐसा रखा है. It can be from t1 to t2 you can put. That's not a constraint over here. अच्छी बात है. Now that should give you what? V. This part is going to be how much? Let's say small v, right? This part is going to give you small v velocity. Now you will be having what? dt 0 to t. Now since the variable now becomes the velocity, so the limit should be from u initial velocity to the final velocity. अच्छी बात है. So that should give you what? V minus u upon, let's suppose, time t. So that is your average acceleration. तो एक बात अपने को समझ में आ गई जी. average acceleration could also be given as change in the velocity upon change in the time. क्या लिख सकते हैं ना? So you can write that A average, चलो, A average should be given as what? Change in the velocity over the change in time. इतनी बातें is clear now. समझ में आ गया जी, all of you? So this is how we're going to find the average velocity, average acceleration and the average speed. कोई दिक्कत इसमें? So एक एग्जाम्पल करते हैं. Let us do one example. चलो जी, let's suppose if I have the position vector of a body is defined as maybe t square plus 2t plus 1. So this is how the position vector of a body or an object is defined. It depends upon the t. Let's suppose time. It depends upon the time. If I ask you, and let's suppose the body is moving in the positive direction, rightward, in the positive direction of x-axis. अपन ऐसे जा रहा है towards right. All good? कोई दिक्कत इसमें? तो I want you to find number one, displacement at time t, or maybe say in time t is equals to, let's say, 3 seconds. Also, I wanted to find instantaneous velocity at time t is equals to 3 seconds. Now, number 3, what you can find is average velocity, or maybe you can find acceleration. चलो वो भी निकाल लेते हैं जी. Acceleration क्या दिक्कत है, उसको भी ले लेते हैं. Acceleration at time t is equals to 3 seconds, or what else you can find is the average velocity in time t is equals to 0 seconds to t is equals to, let's say, 3 seconds. चलो इसको देखते हैं अभी. So if I want to find the displacement in time t is equals to 3 seconds, so basically how much has it moved, that's what we have to find out. तो उसके लिए अपने को we need to understand one thing, कि this x over here is showing you the position vector. It is showing you the position vector. That would help you to figure out, that will help you to understand where the body is at a given time interval. So if I want to know at time t is equals to 0 second, what is the position of the body, we need to figure out, we need to replace the value of t as 0 in this equation. So the position would be given as how much? Just 1. It means at time t is equals to 0, the body is at position 1 on the x-axis. So we can say the position of the body on the x-axis at time t is equals to 0 could be how much? 1, 0. So this is 1, 0. So at time t is equals to 0, the body is here. All good? Now, let's say how much has it moved in 3 seconds, or you can say in time t is equals to 3 seconds. So this is the time t is equals to 0. So I'm not asking the displacement at time 3 seconds. Understand this point. In time 3 seconds. So in time 3 seconds, basically it should be somewhere, let's suppose here. So in time 3 seconds, you can easily do what? You can figure out. So basically in time t is equal to 3 seconds, we'll count from here. So let's suppose this time interval is 3 seconds. Because this is time t is equals to 0 for me. So this is going to be the time interval equals to 3 seconds. So let's say at time t is equals to 3 seconds, the position should be how much? 9 plus 6 plus 1, that means how much? 16, okay. So this position is going to be how much? 16, 0. Now what is the displacement, my dear? Displacement should be this particular length, isn't it? That should be the displacement. It was at 1, it is now at 16. It means the net displacement which it has covered is 15 meter. Please do not write 16 meter. That's going to be wrong answer. ये बातें clear है? Is it clear to all of you? We are asking in 3 seconds how much distance has it moved. So at time t is equals to 0, it was at 1 meter. Already it was at 1 meter. And at time t is equal to 3 seconds, it is at 16 position. At time t is equals to 3. So it is at a position which coordinate is given as 16, 0. That clearly indicates that the body has moved only for the 15 long meter. So if you write 16, it is going to be wrong. So be just careful about that. Anyways, come to now number 2. So one we have finished. Come to number 2. Instantaneous velocity at time t is equals to 3 seconds. Of course, if at time t is equal to 3 seconds, let's suppose the body is here. It could be moving. It could be at rest also. Probably, So let us figure out velocity. Velocity instantaneous should be how much? In this case, dx upon dt. So I'm going to differentiate this. That should be how much? 2 times of t plus 2. That's it. Well, I want to find the velocity at time t is equals to 3 seconds. Well, that should be given as 6 plus 2. That is 8 meter per second. So for this one, the answer is 8 meter per second. Answer is 8 meter per second. For this, answer is how much? 15 meter. Simple as that. Means the body is moving at 8 meter per second at this particular time. The next one is to find the accelerations. Okay, so this was for the second one. The next one is to find the acceleration. Acceleration. And at what time you have to find? At time t is equal to 3 seconds. Okay, ji, koi nahi. So first of all, we know that velocity is given as how much? 2t upon 2. Sorry, 2t plus 2. So the acceleration we know that is going to be how much? Instantaneous dv upon dt. Well, that should be how much? 2. Well, this acceleration is independent of the time. That means the body is moving with a constant acceleration. So the acceleration at time t is equal to 3 seconds should be 2 meter per second square. So answer for this question is 2 meter per second square. Now the third one, what they're asking is to find the average velocity in the time t is equals to 0 seconds to time t is equals to 3 seconds. All right. If I want to find the average speed, we had discussed about that, right? Average speed. How do we get it, man? So average speed should be v dt integration from the whatever time limits it is given. Maybe we can just choose 0 to t from, and here we have 0 to t. They are asking us what? In time 0 is equals to time 0 to 3 seconds. तो कर लेते हैं ना, not a big deal, कर लेते हैं. Number 4th. So number 4th should be average velocity. Average velocity they are asking. V average. हाँ जी. तो कर लो फिर. What is the equation of velocity? 2t plus 2. लिख लेते हैं जी. Let's put it up here. So 2t plus 2 dt, and the time limit is how much? 0 to 3 seconds. So let us put 0 to 3, and here we have what? dt 0 to 3. No big deal, bacha party, right? Okay. So here we have. Now that's going to be how much? 2t square upon t plus 2t, and here we have what? 0 to 3. Going further, this is going to be how much? T, and the limit should be 0 to 3. So this is going to be gone. We'll be having t square. Put the initial limit, that's upper limit, which is 3. So 3 square is how much? 9 plus 6. Negative 0, 0, 0. So it's going to be 0 upon how much? 3. So 15 by 3 is going to be how much? 5 meter per second. So that is your average velocity for this time period, 0 to 3 seconds. All good? Now, they can also ask you to find the average acceleration. कर लेंगे कोई नहीं. So anyways, the acceleration is a constant value over there. तो ज़्यादा कुछ फर्क अपने को पड़ने वाला वो है नहीं. But फिर भी देख लेते हैं इसको. Now, so we know how to solve stuff like this. Instantaneous, average, जो भी अपने को निकालना हो, we can easily figure it out. ठीक है जी. चलिए. अब थोड़ा चलते हैं हम लोग आगे. एक और तरीका है एवरेज वेलोसिटी निकालने का, और एवरेज स्पीड विल बी हाउ मच? यू कैन से डिस्प्लेसमेंट, नेट डिस्प्लेसमेंट ओवर द टाइम. तो इधर से देख लो जी. 15 इज द डिस्प्लेसमेंट. टाइम इज हाउ मच? देखो 3 सेकंड्स. तो 15 by 3 verified. तो the idea was very simple. Don't get trapped with this answer 16. अपन को नहीं ट्रैप करना है. We have to be careful with that. कि what question is asking. So first thing is very important. Question by ध्यान से पढ़ना. All right, everyone, read the question carefully. Now, let us talk about the motion in one dimension. अपने को थोड़ा पता होना चाहिए जी कि what is the motion in one dimension. You guys can find a lot of questions on this instantaneous average velocity. Easily मिल जाएगा. I'm working on that to provide you some questions after end of every video lessons. Hopefully I will be able to get it done ASAP. हो जाएगा जल्दी वो. I'm working on that. And if you're working on that, definitely वो will get over. काम होगा. That is for sure. Anyways, now the next thing that we need to understand is the motion broadly categorized in two terms. Three parts over here: motion in one dimension, motion in two dimension, and motion in three dimension. For your syllabus, motion in 1D and 2D is essential, important. 3D, very rare, some here and there you might be getting, but for your syllabus, motion in 1D and 2D is important. तो हम लोग उस पर ज़्यादा फोकस करेंगे. We're gonna be focusing more on that. तो पहले समझ लो भाई, what is the motion in one dimension and what is motion in two dimension? How are they different and how we can understand the difference between these two? समझते पहले उसको. So when we say that, let's say a body is moving with certain velocity v, एक कोई object है ये move कर रहा है. Its displacement will be in this direction. Let's suppose the body is also accelerating in this direction. So you can see that all the parameters, displacement, instantaneous displacement, that's the reason why I have given it ds, not the complete s. So instantaneous displacement, the velocity and the acceleration, all of these are in the same direction. ठीक है ना? Collinear अभी है. Now maximum what could happen? There are going to be one more situation where let's suppose the velocity is in this direction. So definitely instantaneous acceleration would be in this direction. But let's say if the acceleration is in this direction, ulta, opposite. Now what is the difference in these two? And what is the similarity in these two? Difference is acceleration and the velocity vector are opposite in this case, and over here they are in the same direction. That is the dissimilarities. Similarity क्या है? Still they are collinear. They are acting along one line only. No components of A, ds or v would go in any other dimension. All of these would be in the same. Either they're going to be in the same direction or in opposite. What going to be opposite? Of course, A and B. V and ds can never be opposite. So you can just make a note. Important thing. Note. Instantaneous displacement, लिख लो इसको. Instantaneous displacement is always in direction of instantaneous velocity. हमेशा उसी के डायरेक्शन में जी होगा ये. ठीक है बच्चा लोग? That is not going to be opposite. What could be opposite is the acceleration vector and the velocity vector. A ऊपर नीचे आगे पीछे हो सकता है जी. But still they are collinear. And no components of these parameters are in any other coordinates. So basically when, लिख लो, what is the meaning of 1D? So when all three parameters that is V, A and ds are collinear, it's called motion in 1D. It's called motion in one dimension. I'm writing 1D to represent one dimension. कोई दिक्कत नहीं है ना? So that is the motion in one dimension. We can also have the motion in two dimension. It means the parameters would change in two dimension. As simple as that. Collinear नहीं होगा. For example, if let's suppose a body is moving in this pattern, making some angle, let's suppose कुछ भी बना लो 60 degree with the horizontal x-axis. Now we know that from the vector components, a part of the velocity would be acting along this and a part could be acting along this. And of course this is going to be your v cos of 60 degree and this is going to be v sine of 60 degree. Now you can see that the components of this velocity are getting diverged in two dimensions, So whenever the component of the parameters could be could be written in the 2 dimension, that is called motion in 2D. Let's say, for example, if I write velocity is equals to 2I cap plus 3J cap. Dekho, its component is along the x-axis as well as along the y-axis. So this is called motion in 2D. So when components could be written in 2 dimension, it's called motion in 2D. So now we are going to be more focused on the motion in 1D. हम लोग इस पे चर्चा करेंगे जी, and then we gonna move on the motion in 2D. बहुत अच्छे, चलो लिख लो motion in 1D, motion in 1 dimension, and the basic criteria for the motion in 1 dimension is it should be collinear, and this is the standard format of the motion in 1 dimension. एक और होता है, लिख लो motion in 1 dimension का. Even if you throw the object upward, vertically up, if you throw the object upward, with certain velocity, let's suppose u, it's moving only in the y direction, right? It has no components in the any other dimension. This is also the motion in 1D. If any object is falling, then also its motion gonna be in 1 dimension. हम लोग इस पे भी चर्चा करेंगे. We can also discuss on this. All good? चलो थोड़ा सा इसको erase कर लेते हैं जी. Let us erase this one. So I'm sure you guys are now clear with the motion. When do we call the motion to be in 1D and when do we call the motion to be in 2D? 3D में क्या होगा? I cap, J cap and K cap would come. That is the motion in 3D. So of course we know to represent a motion, to study the motion, we need its parameter, and those parameters should be velocity and acceleration over here, let's say. So velocity, we know what? It is given as ds upon dt. That means what? The velocity would always be in the direction of change of the instantaneous displacement. Simple si baat, always in the same direction. Now, A is written as what? dv upon dt. What do we mean by this? इसका simple सा बात है, लिख लो, important चीज है. Do we have the direction of acceleration and the velocity in the same direction? Do we have the direction of A and V same? Can I say that from here? Yes, I can say that. हम लोग बोल सकते हैं. Now, if I have something like this, A is equals to minus dv upon dt. अभी क्या होगा जी? What do you mean? What could you say about the direction of acceleration and the velocity? So basically, as of now, we cannot say anything about the direction of acceleration and the velocity. Not from any of these. कुछ नहीं बोल सकते. What we can conclude is the direction of acceleration and the direction of change of velocity, because this is your dv by dt. What I have used over here, that velocity is always in the direction of change of the instantaneous displacement, right? हमेशा उसकी directions में होता है. So you can say that over here, direction of acceleration is along the direction of change of velocity, change in velocity. And this would say opposite. A is opposite to the change of velocity. इसको simple terms में बोलते हैं deceleration. This is called a negative acceleration or deceleration, and it will bring the body to the rest, or maybe just slow down. If not at rest, if it is stopped in a time before it was supposed to come at rest, but still it is going to decrease the velocity. उसका velocity को जी कम कर देगा, है ना? ये तो simple बात है, हम लोग समझ गए, कोई इसमें बड़ा बात नहीं है, है ना? But keep it in mind that when we have A equals to dv upon dt, that means direction of A is along the direction of change of the velocity, right? And if it is negative, it is going to be in the opposite direction. दोनों अपना अपना opposite में होगा जी, not a big deal, है ना? थोड़ा और इसको देखते हैं. Let us see something more about this. If I talk about the acceleration, हम लोग को पता है कि we can have the instantaneous and the average acceleration. Acceleration भी दो तरीके के होते हैं. We have two kinds of acceleration. So broadly, if I say the acceleration could be वन कुड बी द कांस्टेंट एक्सेलरेशन, और जो दूसरा हो सकता है दैट कुड बी अ वेरिएबल. Acceleration can also change, as I've told you in the previous videos, based on the force that can also change. So we can have variable acceleration. Variable acceleration. कैमरा ऑन है कि बंद हो गया जी? बहुत अच्छे, फिलहाल तो ऑन है. ओके, ग्रेट. हाँ, so कहाँ थे हम? So acceleration could be a constant acceleration or it could be a variable acceleration. अभी हम लोग बात करेंगे इसके बारे में, the constant acceleration. That is the subject of our discussion for now. All good? थोड़ा देखते हैं इसके बारे में. इसको साफ कर ले, है ना? थोड़ा इसके बारे में और चर्चा करते हैं. Let us discuss more about the constant acceleration. उसके बारे में थोड़ा और हम लोग चर्चा करते हैं. What do we know? A could be written as dv upon dt, let's say. That means if I put, let's say, dv, that could be given as what? A dt, रख लो इसको ऐसे, है ना? Let us integrate both the side. V limit should be u to v, and here we have 0 to t. Correct जी? All right. But चलो, तो what is going to be over here? V minus u is equals to a times of t. है ना? So V could be written as what? U plus at. Oh भाई, this is the first equation of the motion. अपने को मिल गया. We can also derive it with the help of graphs and all. हम लोग उसका भी चर्चा करेंगे बाद में. फिलहाल देखो, this is how we can figure it out. बहुत बढ़िया. चलो, अब थोड़ा और देखते हैं इसके बारे में. Velocity, could it be written as let's say ds upon dt? लिख ले. किसी को दिक्कत? Of course not. बहुत अच्छी बात है. ये हो गया जी आपका number 2. Let us take this dt that side. So we're going to be having what? ds equals to u plus at dt, and now if I do the integration, displacement कहाँ से कहाँ तक रख ले? 0 से s तक रख लेते हैं जी. Let us take it from 0 to s, and time let's say 0 to t. Now this is going to be how much? S equals to, if you do the integration, ut plus 1 upon 2 at square. Limit put करने से ही मिलेगा अपने को. So this is the second equation of motion. I'm sure you guys are familiar with this. 10th में हमने देखा था. अगर familiar नहीं है तो बहुत पीटोगे. सारे पढ़ चुके हो आप लोग ये सब 10th में. हाँ, ये entire process you have not discussed, but you know these all stuff from since class 9th. अब आते हैं, थोड़ा आगे बढ़ते हैं. Before I get into the next one, I would like to tell you something. थोड़ा और बात करते हैं. Velocity के बारे, A के बारे में बात करते हैं. Let us talk a little bit more about A. A is what? A is equals to dv upon dt. Can I just write A equals to dv upon dx into dx upon dt? किसी को कोई प्रॉब्लम नहीं है ना? कैंसिल dt, सेम थिंग, राइट? What is dx by dt? Velocity हो गया, है ना? तो A should be how much? V dv by dx. इसको लिख लो, याद कर लो, रात के 2 बजे भी याद होना चाहिए. A is equals to V dv by dx. Important है भाई. This is important, है ना? बहुत जगह gonna be used it. Okay, we're gonna be using it quite some time. मजाक नहीं कर रहा हूँ. Important है. I want you to just have this entire process in your mind. जैसे मुझे याद है वैसे भी आपको याद होना चाहिए, without any doubt. आगे बढ़ते हैं. Let me just use this one. So what we're gonna have? A equals V dv upon dx. अभी मेरे को बताया गया है. Let us take it this side. So we're gonna have what? A dx is equals to V dv. कर लेते हैं जी, है ना? Since we're dealing with the constant acceleration, that means A is a constant. Can I just take it out and put this dx and V dv as it is? 0 to आप रख लो, s रख लो. ठीक है ना जी? तो अगर मैं यहाँ पे लिखूं भैया कि just to avoid your confusion, मैंने यहाँ पे s ही रख लेते हैं, because the entire thing we are dealing with s. बाद में बोलोगे सर आप x और x में कहाँ फर्क करते हो. Let's have it here. कोई दिक्कत जी किसी को? Any problem? बहुत अच्छे. अब थोड़ा आगे बढ़ते हैं. This is going to be how much? s if I do the integration. ये लो जी. And integration of v is how much? इसका लिमिट पुट कर दो ना. फिर बोलोगे सर लिमिट भूल जाते हो आप. This is going to be how much? V square upon 2. Lower limit is u, upper limit is v. अब ठीक है भाई, ये हो गया v स्क्वायर माइनस u स्क्वायर अपॉन 2. चलो 2 को उड़ाकर इस तरफ ले आते हैं. लेट अस ब्रिंग दिस टू दिस साइड. वेल दैट इज गोना गिव यू व्हाट, 2 टाइम्स ऑफ as इक्वल्स टू v स्क्वायर माइनस u स्क्वायर जी, है ना. तो देखो यहाँ से क्या मिल गया अपने को, v स्क्वायर इज इक्वल्स टू u स्क्वायर प्लस 2as. ये हो गया आपका जी थर्ड इक्वेशन ऑफ मोशन. ये आपका तीसरा इक्वेशन हो गया बच्चों. तो जस्ट मेक अ नोट ऑफ दीज थिंग्स, एक साथ लिख लो. बोर्ड में एग्जाम में पूछ देगा तो यू कैन सॉल्व इट. बाकी तो अपने को पूछता नहीं है बाकी इन अदर एग्जाम्स, बट इन द बोर्ड एग्जाम्स हाँ पूछता है. स्कूल एग्जाम्स में दे कैन आस्क यू टू डिराइव बाय द मेथड ऑफ कैलकुलस. तो भाई ये कर देना, कोई दिक्कत नहीं है, पूरे के पूरे मार्क्स मिल जाएंगे. One more thing I want to add before I start doing some numericals. Whenever we have the motion in 1D, you have the complete authority to choose a positive direction and a negative direction for one particular question. But stick to that for the same problem, not for the entire life. But उस problem के लिए, if you have taken the right as positive, बस वही positive आपके लिए. बीच में left right मत करियो, you know you're gonna go wrong. एक बार right ले लिया तो ले लिया, ठीक है. What exactly I mean to say कि if I take the right direction as a positive for a particular problem, then the left has to be negative. No. I mean like confusion on that. All right. इसमें कुछ ज़्यादा डिस्कशन की बात नहीं है. And or if you take left as your positive, then the right has to be negative. Likewise, if you take the upward as a positive value, then the downward has to be negative and vice versa. नीचे positive ले लोगे, ऊपर negative हो जाएगा. But just to avoid any sort of confusion, what we should do, हमेशा एक तरफ को positive मान के रखो. I follow this one. आप चाहो तो इसको follow कर सकते हो, negative positive खेलो, कोई दिक्कत नहीं है. But just follow one streak and life would be simple. तो मैं हमेशा ऊपर को positive मानता हूँ, नीचे को negative. कोई खास discriminations नहीं है. there is no bias towards left or right. That right has to be positive or left has to be negative. But हम लोग इसी को follow करते आते हैं. तो let's just try and make it simple. Let's not have anything. यहाँ पे उल्टी गंगा बहाने का अपने को जरूरत नहीं है. जहाँ होगा वहाँ पे बहाना, ठीक है. Anyways, so this is done. अब थोड़ा vertical motion का भी समझा देता हूँ इसमें कि what's gonna be the difference. Though vertical motion is also the motion in one dimension, but थोड़ा बहुत difference है, देख लेते हैं उसको. And the difference would be because of the gravitational acceleration, है ना. वो जो हमेशा नीचे की ओर आपको खींचता है, जिसने न्यूटन को न्यूटन बना दिया. वैसे न्यूटन था महान आदमी. अगर न्यूटन उस एप्पल गिरने से मर गया होता, like there's a lot of memes saying कि you know if that would have been a coconut, तो हमारा 11th 12th बच जाता है ना. Anyways, ठीक है, देखते हैं vertical motion थोड़ा सा डिस्कस करते हैं जी. So two cases I would refer now. Case number 1, when the body is thrown upward. और दूसरा केस देखेंगे जब बॉडी को नीचे फेंक रहा है. और थर्ड when it is dropped. ये तीन केसेस अपने पास आते हैं. Let's say when the body is thrown upward, है ना, ऊपर की ओर with some velocity u. इनिशियल स्पीड ऊपर की ओर फेंक रहे हैं एंड बॉडी ऊपर कहीं जाके रुक गया. और लेट्स सपोज कि यहाँ पे आके वो रुक गया जी. एंड दैट हाइट इज लेट्स सपोज h. इधर आके बॉडी स्टॉप्ड. हियर द बॉडीज वेलोसिटी बिकम्स 0, फाइनल वेलोसिटी. ठीक है ना. तो देखो सिंपल सी बात है. व्हेन द बॉडी इज थ्रोन अपवर्ड, देयर इज सम फोर्स व्हिच इज पुलिंग इट डाउनवर्ड, एंड ड्यू टू दैट फोर्स व्हिच इज कॉल्ड ग्रेविटेशनल फोर्स, वी गेट एन एक्सेलरेशन that acts downward. हमेशा वो नीचे की ओर काम कर रहा होगा. वो नीचे की ओर downward, है ना. अच्छी बात है. From the if I want to find how much height has it moved, है ना, height, maximum height, तो क्या होगा जी. अपने को फॉर्मूला पता है, ut प्लस हाफ at स्क्वायर. अभी लिख लो इसमें. चलो ठीक है, ऐसे लिख लेते हैं. We know that s is equals to ut plus half at स्क्वायर. I take upward as positive. As I've told you, मैं एक हमेशा ऊपर मानकर पॉजिटिव चलते हैं. तो s is how much? Height. u is upward, ऊपर की ओर है, पॉजिटिव t प्लस हाफ. ये जो भाई सब एक्सेलरेशन है ना, ये हमेशा नीचे की ओर पुल कर रहा है. इट इज पुलिंग यू डाउनवर्ड, एंड तो दिस शुड बी हाउ मच? माइनस g t स्क्वायर. सो व्हेन द बॉडी इज थ्रोन अप, you guys have been taught कि you remember ut minus half gt स्क्वायर. आप ऐसे याद कर लो, वेल एंड गुड. नहीं तो रिमेंबर दिस एंड रिमेंबर द साइन कन्वेंशन, कभी गलत नहीं होगे, यू विल नेवर बी गोइंग रॉन्ग. सो व्हाट आई डू, आई एम टेलिंग यू माय स्टफ, आई ऑलवेज रिमेंबर लाइक दिस. बट हाँ, ओवर द पीरियड ऑफ टाइम प्रैक्टिस करते करते द मोमेंट यू फील द बॉडी इज गोइंग थ्रोन अप, आपके दिमाग में फटाक से आ जाएगा, लिख दोगे, निकल जाओगे, कोई दिक्कत नहीं है. अच्छा ठीक है. सो दिस इज व्हेन वी हैव अचीव्ड द मैक्सिमम हाइट. अगर कोई पूछ दे कि भैया यहां से थ्रो करा गया विथ सर्टेन स्पीड u, किसी एक टाइम पे बिफोर इट केम टू रेस्ट, किसी एक टाइम पे एट एनी टाइम t, you have to find its velocity. चलो कोई नहीं, नो बिग डील. किसी एक टाइम पे बिफोर इट कम्स टू मैक्सिमम हाइट, इधर ही केम, सपोज लाइक इधर है, ठीक है. इन दैट केस वी नो व्हाट v इज इक्वल्स टू u प्लस at, दैट इज द इक्वेशन ऑफ मोशन, फर्स्ट इक्वेशन ऑफ मोशन. अच्छा, v is gonna be upward, while it is going upward, the v is gonna be upward. ठीक है, मेरे को पता नहीं है ऊपर है कि नीचे, ऊपर लिख, फिर भी लिख लो v. u definitely was upward. ये जो भाई साहब a है ना, it is downward, माइनस gt कर दो, तो v is equals to u माइनस gt अपने को देखने को मिल जाता है. क्लियर बात है ना. तो with this thing, when the body is thrown up, we can find the height, we can find the velocity. और कोई पूछ दे कि भैया किस टाइम पे the velocity would be zero, at what time the velocity would be zero, कितने टाइम में velocity zero हो जाएगा. So time at which the velocity is zero, velocity is zero, कोई नहीं, no big deal. We know v is equals to what, u minus gt, अभी कभी किया रहा हमने, v is equals to gonna be 0 u minus gt. That means t will be how much, u upon g. अच्छा जी. So this is the time when the velocity would become zero. It means this is the time to reach the maximum height. This is the time it takes to reach the maximum height. अच्छा अच्छा ठीक है, कोई बात नहीं. You must know one thing. The time it takes to go up will be same as the time it takes to come back to the same position from where it was thrown upward.